Hello, everyone. My name is Sharath, as Madan said, and good afternoon, good morning, good evening to everyone. And folks in India don't sleep. I'll only take 15 minutes. So, but the problem is I have 40 slides, which will take more time, right? So that's why I'm going to the Jupyter Notebook, and I'm going to show you how we can run lightweight MMM orbit, and I will do the direct comparison between three. Okay, because Robin, you already seen that. So the thing is, okay, let's start with the lightweight MMM. So lightweight is also known as Bayesian market mix modeling, and it's please note that it's not a Google official Google product. Some guy in Google created this Python library and make it open source. So lightweight MMM is basically a Python library that helps organizations to understand and optimize marketing spend across media channels. So that's it. And the simplified model overview, the model form is KPI is equal to alpha plus trend plus seasonality plus media and media channels plus other factors. Basically, what it means that it uses trend, seasonality, and media channels, which is independent variables, and other factors as in events and other activities. So those are incorporated in the model so that we can predict the relation between media channels and sales, right? So this is the model form. So if you want to go deep and to find out what are the exact mathematical equation for each term, you can click here and go to the documentation and see what is exactly the equation. So I'm not covering that portion. Okay. So the key feature of key feature of lightweight MMM is we can model it in national and geographical level. So if you model it in geographical level, it will give you more accurate results because it is more granular data is in the media data. In the data level, right? Input data. So that's one of the main feature, and the transformation method, right? So earlier we are talking about add stock methods. So hill add stock and geometrical add stock for Robin. So here there are three add stock methods used. One is add stock, second is hill add stock, and three is carryover. These are names. So add stock basically applies an infinite lag that decreases its weights as time passes. As a normal lag effect, right? Lag means its weight is decreasing when time passes. That's the idea. And Hill add stock uses sinusoidal like function. Basically, the effect will last for a particular time and it goes suddenly and fades away. So that is the kind of function. And carryover is the interesting function. It applies a causal convolution, giving more weight to the near values than distant ones, which is actually very interesting, and it's a very good uh, add stock technique. Okay, so now I'm going to show you what the overall idea of uh, modeling workflow. First, we need to prepare the data by using pre-processing and scale the data. Then we will train the data using the lightweight MMM library. Then the model diagnostics. We will after fitting the model, we have some set of diagnostics checks whether the model is good and bad. Some checks are convergence check, fitting check, etc. Then we optimize them. We run the optimization, and we say if the model is good, then we save the model. Okay. So that this is a basic workflow. I'm not covering in a deep. So just showing that here we install the library, and we are using perfect gene data for this experiment. Basically, I'm using the same data across all the three models, right? Lightweight, Orbit, and Robin. Okay, so last 2 years data, I have taken the 2 years data. So I will show you how this model works basically. So first I feed the data into the parameter called model data. Then I do some basic EDAs here. Then after that, these are basic EDAs, and I need to find out which there are two sales. Response value, first time orders and returning orders. So I just want to know how the new customer, how the media is affecting to the new customer. That's why I'm using first time orders to model, right? So then what do I do is, basically assigning all the values to the modeling parameters, all the media values, media. values. For example, we have Google, Facebook, and TikTok data is available here. So I'm adding Google click, Facebook impression, and TikTok impressions as media values. And we have actually detected a scenario on Black Friday. So to covering that thing, we are using events as an extra feature into the model. And yeah, we are modeling the first time visitor, first time orders. That's why it's target. And one important feature of this model is priors, usage of priors. So this model use priors. Basically, the cost data we are loading is as cost, and it uses. I mean, it is very helpful in this model, right? Okay, so after that, we will split data into two different segments for training and for testing, right? So I'm taking last 12 weeks of data for testing and remaining data to training, right? The scaling is applied. We scale the data for the modeling, and after that, also we do some correlation test, variance test, and some variance inflation factor test as well. So, after all these things, we train the model, fit the model, and we check. After the model, we need to find out whether this model is good or bad, right? So for that, we do convergence check and fitting check. For fitting check for this model, I can see that the R square is 92% and maybe is 12%. For the training data, it fits almost okay. I mean, I think it's good. And for predictive check, we do the prediction on the test data, right? So using the coefficient of that model, we predict on the test data. Then we can see that 86% of R square and 18% maybe is there. So yeah, and we can also, using the lightweight MMM model, we can also find the media effectiveness. We can see that Facebook has more effect than compared to the Google and TikTok. And ROI, we can also calculate ROI, and finally we can calculate baseline contribution as well. So this is just a workflow. Okay, that's it. We can go and do a lot of analysis here, but I'm not covering all those things. So basically, this is the workflow. This is how you can run a lightweight MMM. I think it's comparatively easy. Okay. Now we are going for a raw orbit model. So the modeling technique is a Bayesian time varying coefficient model. So this is the earlier we said lightweight is a Bayesian modeling, but orbit is a Bayesian time varying coefficient. The model form is YT equal to LT plus ST. Basically, L stands for trend, S seasonality, R for regressor, epsilon for modeling error. So what is the difference here? Difference is time. You can see that for each time there is a coefficient, right? Each time. That is the importance of this model, and that's why it tracks, it predicts well compared to other models. Okay, so the key feature is that Orbit's BDVC model adjusts coefficient in real time to reflect evolving marketing effectiveness. So that's really interesting. And handling seasonality. So they use some inbuilt seasonality function to handling seasonality very much. But the problem is they don't use ad stock here. Okay, so this is one difference. And I mean, there are a lot of difference. This is second difference or something. Okay, all right. So basically, this is also a Python library. So Orbit has multiple models present. So, but we are actually looking into kernel-based a KTR model, kernel-based time varying regression, which uses this time varying technique. Okay. So same scenario, we install the library and we load the data, same data, I'm using the same data. Okay, so we run this model. So this is the modeling. I'm gonna show you this. Okay, so we split the data into train and test set. Then after that, this is the model. Okay, this is the model run, training. Okay, KTR and KTR is the model name, right? Okay, then we pass all these values and we fit the model here. Okay, so after that we predict the test set. Okay, here you can see that this is the plot, and these dots are the train response, actual response, and these yellow dots are the actual response in the test set, and this is in the training set. Okay, and this line is the prediction. So you can see that it's predicting almost brilliantly in the training set, but it's not up to the mark in the test set, right? So the BTVC model has another set of function. I mean, another scenario where we can incorporate seasonality, right? So the seasonality, I have introduced a seasonality in this function. So for 1 year seasonality, basically 52 weeks. So then I can see that I do the model, I train the model. I can see that it's predicting a little bit better when compared to the early one, right? So, but I think I need more. Okay, then I try to introduce a regressor, basically uh, priors kind of knowledge, right? Yeah, regressor. As when I have passed the Google spend, Facebook spend, and TikTok spend as regressor column, and I've trained the model with that. Okay, then I can see that it's predicting compared to that, it's predicting better. Okay, so this is how this model works, and one of the important factor is the uh, coefficient of each regressor is changing, or the coefficient is changing for time. I mean, change based on the time it's changing. You can see that, the prediction coefficient is changing here. So that is the case. Basically, we are using this equation, right? So what's the equation? Yeah, yt is equal to lt. So for each timeline, there is a coefficient. That's why that's a strength, one of the strength of Orbit. Now, what I'm going to do is I'm going to do a direct comparison for all the three models. Okay, so the modeling approach is Bayesian for lightweight MMM. It's Bayesian time varying coefficient for Orbit, and for Robin, different. I mean, AI and ML driven regression techniques are used. For example, ridge regression, Evergrad, and Prophet are used in Robin. And language, lightweight and Orbit use Python, but Robin uses R. Okay, and the ease of use, yeah, ease of use. Well, lightweight, very easy to run things, but in Orbit we need advanced, because we need to take the coefficient, and there are a lot of expertise needed, basically. So Orbit is, that's why it's very advanced. For Robin, easy with guided analysis, I would say, like that. If you run it once or twice, it is very easy. Okay, then execution speed is it's Robin is slower compared to lightweight and Orbit. I think lightweight and Orbit, for me it was quick and almost equal. Okay. Sorry. So then data integration, we use Python for integrating data, simplified Python. For Orbit, Python based with custom going for AdStock. AdStock. Basically, AdStock is not in the Orbit, but I can introduce manually. Okay. So, and Robin is a detailed R integration. Yeah, for data integration, we need to use R for Robin. Okay, and focus area analysis. This is where lightweight is. I mean, I would say everyone has different focus. Okay, so lightweight focuses on hierarchical modeling. That means allowing analysis at different levels of aggregation. For example, we can aggregate channel, sub-channel, and focus on a particular area to understand what's happening. That there are positive and negative for that, but this is the positive side. Okay, and Orbit is time sensitive analysis. As you know that capturing the dynamic effects of marketing activities on KPI, they use that time varying technique. Okay, and Robin is more focused on channel wise, so that you can you can optimize each channel, and yeah, that's the main purpose of focus of Robin. Okay, and next one is forecasting capabilities. Lightweight is probabilistic outcomes. So basically, when I show you the lightweight graph, you can see the shades, right? So that is actually those are the potential outcomes of the model. So lightweight's doing that, but Orbit actually they are more the prediction. Yeah, I mean, you can see that the Orbit dynamic market trend predictions are very accurate. We can see when I introduced seasonality, it was predicting well in the test data set, right? So that is the main focus for the dynamic market. We can use Orbit very efficiently. Okay, and Robin is a budget allocation proposal. Optimize, basically, it's a Robin, when the data is very rich and we need to optimize marketing spend and get the maximum ROI, we can use Robin for that, right? And community support, cost of ownership, training, and documentation. I would say Robin performs very well here. We have an active group of community and well documented in Robin. And cost of ownership, I would say it's variable depending on usage for both Lightweight and Robin. But Orbit needs more money to run because we need a technical resource. Technical resource is very expensive, I think. And training documentation, as I said, Robin has a good one. I mean, I think last three, Robin is performing very well. Okay, and Lightweight doesn't have a document. I mean, it's not up to the mark. It's very difficult to find documents. Okay, so the conclusion is, I would say when the data is very sparse and we don't have that much information and we only have priors, we can go for Lightweight MMM and to get a straight understanding of what's happening in the market. And if the market is very dynamic and it changes every week or every month, and definitely Orbit is a good model. But the problem is we need a expertise to do that modeling. But Robin, in the sense, it's if we have a very good data for normally when we do triple modeling, we require 2 years of data, right? So if you have 2 years of data with a lot of activities in that, and definitely Robin is a good method, and it uses different machine learning techniques to optimization, parameter optimization, and modeling selection. Model selection, then I would say the human touch is very less in Robin, and it's a document. It's very strong. I mean, it's very easy to communicate with the Robin once I understand how to run and how to read the reports and all. So, yeah, that's my conclusion. That's only my personal conclusion. So, yeah.
Great work.